Alright, we're going to go ahead and get started with this lecture video, overview of chemical reactions. In this lecture video, we're just going to give a brief overlook of what chemical reactions are, how we represent them, and introduce the law of conservation of mass to you. So let's start out with looking at a definition of a chemical reaction. A chemical reaction is defined as a chemical transformation or a change that occurs when substances interact and or a chemical bonds are broken to produce new substances with new properties. Chemical reactions are symbolically represented by chemical equations. Right? So for our class, that's essentially what a chemical reaction is in a nutshell. Again, what we normally do is we take materials, molecules, compounds, and we interact them, and during that interaction bonds are going to be broken and atoms will rearrange themselves and new bonds will be formed with those rearrangements, and we will form new substances with new properties. And so if you keep those principles and idea about what a chemical reaction is, you'll do good for the quiz that we'll have over this. Alright, so chemical equations. Down below here, I have a representation of a chemical equation of hydrogen gas reacting with oxygen gas to produce water. Now, in a chemical equation, there are certain things that we have to include to make it correct. First of all, it should always include what are known as the reactants. The reactants are known as the starting materials used to start a chemical reaction. It is the reactants that their bonds get broken in the course of the reaction. We also place an arrow in the chemical equation, and that arrow just represents that we're going to make or we're going to produce something. So on the quiz, I'll probably ask you what the arrow represents. Again, the arrow represents to make or produce something. In this case, our reactants are going to make water, and water is known as a product in this reaction. The products are the new materials made during the chemical reaction. So after chemical bonds have been broken, the atoms are now free to move, and they can rearrange themselves, and then they will form new chemical structures by creating new chemical bonds. Right? So these are important ideas. Now, what else do we have here is we normally put the state that the compound or molecule is in during the course of the reaction. So we usually symbolize by something like this, where we have the physical states. G in parentheses is a gas, a liquid is parentheses L, a solid is parentheses S, and if it's aqueous, meaning that the substance is dissolved in water, then we put AQ, and we just place that at the end of the reactant or the product, as you can see here represented in this equation. Now, what else we include in a chemical equation are known as the coefficients. The coefficients go in front of the products or the reactants, and the coefficients just indicate how many of the type of materials that we have. For instance, this 2 in front of hydrogen represents that we have 2 H2O molecules. That's going to react with one molecule of O2 to produce 2 molecules of H2O. And so those are what the coefficients are, and we'll talk more about the coefficients and the true meaning behind them in class. Alright, so now let's take a look at evidence. in a chemical reaction, there are evidence that or observations that you can make that will indicate that a chemical reaction has taken place. And these are four types of evidence that can occur that you need to be aware of and learn that would indicate that a reaction is occurring. So one is that if you see the formation of a gas, which is usually indicated by bubbles. So if you see bubbles forming during the reaction, a good explanation that a gas is being formed. Two, the formation of a solid known as a precipitate. We'll use the word precipitate quite a bit, and that just means that basically during the reaction a solid is made or formed. Color changes often indicate a reaction has occurred, and the production of heat and light. Alright, so just make sure you know those for the test. Alright, now what I want to do is introduce to you the law of conservation of mass. This is an extremely important law. Essentially what this law states is that during a chemical reaction, mass, or in other words matter, is not created nor is it destroyed. In other words, it means that atoms or matter in general is conserved during a chemical reaction. Hence the law of conservation of mass. So I have a kind of a diagram here of the reaction between water and hydrogen. These are our two hydrogen molecules, and here's our oxygen molecule, and these two are going to react together to end up producing our two molecules of water, H2O. Alright? So, notice that in this reaction, we start out with how many atoms of hydrogen? Well, you have one atom of hydrogen, two atoms of hydrogen, 3 and 4 atoms of hydrogen. So if I start out with 4 atoms of hydrogen and I'm going to obey the law of conservation of mass, then at the end of the reaction I should have 4 atoms of hydrogen, in which I do. 1, 2, 3, 4. So therefore the hydrogen atoms have been conserved during this chemical reaction. What about the oxygen? The oxygen better be conserved as well. So we start out with 2 atoms of oxygen, and in the course of the reaction, when we create water, we also create 2 atoms, or have 2 atoms, not really create. So what I mean here is that all the atoms in the reactants are conserved and are found in the products. So again, it goes back to our definition, what's really occurring during a chemical reaction if atoms are conserved and we're not creating any new atoms. It's simply this: we are going to break these chemical bonds between the oxygen and hydrogen. That's going to allow these atoms to be free so that they can rearrange themselves, and then they will form new bonds between the hydrogens and the oxygens to create our water molecules. Thus, the chemical reaction has occurred, creating new substances with new properties, but keeping the atoms conserved, and therefore the mass is constant. Alright, so that's the law of conservation of matter in a nutshell. Alright, so this ends this lecture video. If you need to relook at it, please do so. Come to class prepared to take a quiz over this information. And that is it for now.